something strange is happening in the constellation of Orion. One of its brightest stars, a familiar red jewel in the winter sky, is behaving in ways we have never seen before. This star is Betelgeuse, a colossal giant nearing the end of its magnificent life. For centuries it burned with a steady, reassuring light, a constant presence in our celestial neighborhood. But recently that constancy has vanished. Scientists with powerful telescopes pointed at this stellar titan have been left scratching their heads, captivated by a mystery unfolding hundreds of light years away. It's a puzzle that challenges how stars live and how they die. What could cause a star this huge to flicker and pulse so erratically? Betelgeuse is more than just a random point of light. It is a celestial landmark. You can find it easily, marking the right shoulder of Orion the Hunter. Fiery orange-red, Betelgeuse's color, brilliant blue-white, Rigel at Orion's foot. For thousands of years, cultures across the globe have gazed upon it. They wove it into myths. They used it to navigate the seasons. Its distinct color makes it stand out. Not all stars are the same. That reddish hue tells us Betelgeuse is a red supergiant, a star in the final magnificent stage of its life, swollen and cooler than our sun. The sheer scale is almost impossible to comprehend. Its surface would extend past the orbit of Mars, perhaps even Jupiter. Hundreds of times larger than the sun, thousands of times brighter than the sun. That immense size means it burns through its fuel at a ferocious rate. Our sun is middle-aged with billions of years left. Betelgeuse is ancient, maybe 10 million years old, already on the brink of demise. It's a ticking time bomb, a window into the violent forces shaping the cosmos, and the creative forces shaping the cosmos, the atoms that make us. In late 2019 and early 2020, something unprecedented happened to our familiar stellar beacon. Betelgeuse began to fade dramatically. This event, which astronomers soon dubbed the Great Dimming, was so significant that its change in brightness was noticeable to anyone looking up at the night sky. The once mighty star, one of the 10 brightest in the sky, had dimmed by nearly 2/3, appearing as a shadow of its former self. This wasn't the star's usual subtle pulsation. This was a profound and mysterious change that sent shock waves through the scientific world. What could possibly cause a star of this magnitude to lose so much of its light so quickly? The initial theories were wild and exciting. The most tantalizing possibility was that this was the beginning of the end, the final pre-supernova collapse. However, as the weeks turned into months, Betelgeuse slowly began to brighten again, returning to its former glory by the spring of 2020. The immediate crisis seemed to be over, but the mystery only deepened. The leading explanation emerged: a massive surface mass ejection. Essentially, the star had burped, flinging a huge cloud of hot gas. As the cloud cooled, it condensed into dust, forming a veil that temporarily blocked the star's light. While that explains the dimming itself, it leaves one big question. Why would Betelgeuse suddenly eject so much material? In the quest to understand Betelgeuse's strange behavior, a bold new theory has recently emerged, one that sounds like science fiction. What if Betelgeuse is not alone? Or rather, what if it wasn't alone? A team proposed a violent explanation. Sometime in its distant past, Betelgeuse may have swallowed a smaller companion star. This act of stellar cannibalism, a cosmic meal on an unimaginable scale, could explain much, including its unusual rotation and the great dimming itself. The idea, Betelgeuse was once part of a binary system. A smaller star orbited it. As Betelgeuse swelled into a supergiant, the companion's orbit decayed and it was pulled into the giant's atmosphere. This wouldn't have been gentle, a cataclysmic plunging of one star into another, injecting energy and material deep into Betelgeuse, churning its interior. A merger would spin the supergiant up, transferring orbital momentum into stellar rotation. This rapid rotation could power intense magnetic activity and massive ejections of surface material. Like the cloud that likely caused the Great Dimming, perhaps a long-delayed aftershock from a violent merger thousands of years ago, it paints a picture of a more interactive, dynamic universe. If true, we are seeing the aftermath, the ghost of a consumed star living on within the giant that devoured it. A haunting legacy that could shape its final turbulent moments before inevitable demise. So, how can scientists possibly know if Betelgeuse consumed a companion star long ago? The evidence, though indirect, is woven into the very light and motion of the star itself. One of the most significant clues is Betelgeuse's rotation speed. Expanding stars are expected to slow, like an ice skater stretching their arms, but Betelgeuse spins remarkably fast. A merger with a companion would transfer orbital momentum, spinning the giant up like a top. That spin alters surface behavior and internal convection patterns. The massive ejection that caused the Great Dimming signals extreme surface activity. A merger would disturb the interior, creating long-lived turbulence. Scientists run sophisticated simulations to predict observable consequences. When models match Betelgeuse's rotation, ejections, and pulsations, the hypothesis gains credibility. Another piece of evidence is absence. We don't see a companion today. If Betelgeuse formed in a cluster, a companion was statistically likely, but it is missing. The neat explanation: the companion isn't missing, it's been incorporated into the giant. Combine spin measurements, surface activity, and models, and the case strengthens. Astronomers are building a compelling case that Betelgeuse's secret is a story of cosmic cannibalism written in light and motion. Swallowing an entire star would have profound and lasting consequences for a supergiant like Betelgeuse. This cosmic meal is more than adding mass. It's like throwing a lit match into a fireworks factory. A smaller star would plunge through Betelgeuse's outer layers, releasing enormous gravitational energy as heat and kinetic energy. That would trigger violent storms inside the supergiant, disrupting the balance between gravity and fusion built over millions of years. The injection of material could temporarily rejuvenate the aging giant, adding fresh hydrogen fuel. Some material could be mixed into regions around the core, boosting fusion processes. The merger could dredge heavier elements up into the envelope, mixing them into the outer layers we observe today. Excess rotational energy powers stronger magnetic fields and more violent stellar winds. That helps explain high mass shedding and the complex dusty environment around Betelgeuse. We could be watching prolonged indigestion, a star still reeling from a feast that reshaped it. This internal mixing and added mass may hasten the final stages of core burning. Cosmic irony: by consuming another star, Betelgeuse may have sped up its own spectacular death. Regardless of whether Betelgeuse swallowed a star or not, its ultimate destiny is certain. It will explode as a Type II supernova. This is the fate of stars more than about 8 times the mass of our Sun. When the core exhausts fuel, it can no longer generate outward pressure. Gravity crushes the core and it collapses in a fraction of a second. A rebound shockwave blasts the outer layers into space, briefly outshining entire galaxies. Predicting the exact timing is impossible. It could be any time within the next 100,000 years. It could be tomorrow night or 1,000 generations from now. Scientists are watching with unprecedented intensity, looking for signs like a neutrino burst. Neutrinos would be the first signal to reach us from the collapsing core. The supernova will be completely safe at approximately 550 light-years, but spectacular, visible in daylight, potentially as bright as the full moon for weeks or months. For scientists, it would be a golden opportunity to test theories about stellar evolution and element formation. After the flash fades, a beautiful remnant, rich in oxygen, carbon, and iron, will seed future stars and planets. The story of Betelgeuse and its potential secret meal is a testament to the dynamic, often violent nature of the universe. It shatters the simple view of stars as isolated, predictable spheres. Instead, it reveals a cosmos of interactions, stars that dance, collide, and sometimes consume each other. The swallowed star idea opens dozens of new avenues of inquiry. By combining powerful telescopes, supercomputers, and physics, we can piece together events from millennia ago. Instruments like JWST may peer through the dust and give us clearer answers. Betelgeuse teaches us cosmic humility. Just when we think we understand, the universe gives us new puzzles. Whether the dimming was dust or the ghost of a swallowed star, the journey to find the answer is what truly matters. It fuels curiosity and drives scientific progress.